In the last presentation, we completed decimal to binary conversion. The next conversion is decimal to octal. For decimal to octal conversion, we have to divide integer part by 8 and multiply fractional part by 8. We are multiplying and dividing by 8 because base in case of octal number system is 8. The base or radix R is equal to 8 in case of octal number system. So we have to divide the integer part by 8 and multiply the fractional part by 8. I will explain this conversion by the help of two examples. In the first example, I will not include the fractional part. We will include fractional part in second example. So let's start with example number 1. The decimal number is 112. This is in decimal, and we want octal equivalent of 112. We have to divide 112 by 8 because we have to divide the integer part by 8, and when you divide 112 by 8, the quotient is 14 and the remainder is 0. We will again divide 14 by 8 and we will have quotient as 1 and remainder is 6. 1 divided by 8, quotient is 0 and remainder is 1, and we will stop here. And this 1 here is MSB and this 0 here is LSB. So the number is 160. We have to start from bottom and we have to go up, right? So 160 is the octal number which represents 112 in decimal. 160. This is the answer. In second example, the decimal number is 25.625. This is in decimal, and we want the octal equivalent of this number. And if you remember the last presentation, this was the example for decimal to binary conversion. I'm using the same decimal number for decimal to octal conversion. We will divide the integer part, this is the integer part, by 8, and we will have quotient equal to 3. 8 3 times will give us 24, so the remainder is 1. I will again divide this 3 by 8, quotient is 0 and remainder is 3. This 3 here is MSB and this 1 here is LSB. So the integer part for the octal number is 3 1, right? Now we have to find out the fractional part for the octal number, and we have to multiply this fractional part by 8. So we will multiply 0.625 by 8 and this will give us 5.000. We will keep 5, we will keep this 5, and after this we are left with 0.000, and we will again multiply this by 8 and the result is 0.000. So we have 1 0, and in the same way if you repeat the process you have bunch of zeros. So we will stop here, and the fractional part for octal number is 50. So the octal equivalent of 25.625 is 31.50. This is the answer. And if you divide this 0 again by 8, you will have remainder as 0, and if you divide this 0 again, you will have remainder as 0. So we are getting bunch of zeros before 3 and we are getting bunch of zeros after 5. The value will remain the same, so we don't usually write the zeros. We will settle with 31.5. Now I have two homework problems for you. Homework problems. In the first homework problem, the decimal number is 2048. This is in decimal, and you have to find out the octal equivalent for 2048. In second problem, the decimal number is 82.250. This is in decimal, and you have to find out octal equivalent of this number. So these are the two problems for homework. Once you have your answer, post it in comment section. This is all for this presentation. See you in the next one.